Hello everyone, this is Dr. Zach. Today we are going to talk about central tendencies, which is just a fancy way of saying mean, median, and mode, as well as the range, and we're going to think about outliers. So a mean is just an average of the data set. Remember, you're going to add all the numbers and divide by the number of items. The median is the middle number, or for when your data is listed in order. The mode is the number that occurs most often, and remember, it is possible to have no mode within your data set. The range is the difference between the greatest and least numbers, so that'll be the largest number minus the smallest number. An outlier is a point that just doesn't make sense with the rest of the data given. It's either much greater or much less than all the rest of the data. So we're going to start out by looking at Niles, who has scored 70, 74, 72, 71, 73, and 96 on his 6 geography tests. So 96 is kind of out of the data range for the others. It's called an outlier. So write that on your paper, please. It is an outlier. For each question, we're going to choose the mean, median, or mode and give a reason for that choice. So which measure gives Niles test average? So to test average, remember average is mean, and we would use the mean to find an average. In order to find the average, we're going to take 70 plus 74 plus 72 plus 71 plus 73, and we're going to include the 96. So this includes the outlier unless you're told to otherwise drop it off. We have 1, 2, 3, 4, 5, 6 pieces of data, so we're going to take those numbers and divide by 6. And when you do that, you get a 76. So the mean is a 76%. Now the outlier is causing this 76 to be a little bit larger average when we look at his other data. So we might also want to think about the different data in a different way. What if we were to think about which measure best describes Niles' typical score? So there are a couple ways you could do that. You could think about the mode, but he got a different test score on each one of his tests, so the mode is not helpful here. The other idea that might help is the median. So if we look at the median, that means put your numbers in order first. So we have our 70, 71, 73, 74, and then I lost the 72. It belongs in here, as well as our 96. So squeeze that 72 in. So the median is somewhere between 72 and 73, because it's the data halfway. Our median is then 72.5. So that might be a better indication to a person as to how well Niles is doing in class. So our explanation was the median might be better because of the outlier. So the idea here, instead of just doing what you are told, you're going to think about our central tendencies and which central tendency would be best to describe what's happening in our data. So question A, number 1, you're going to find a measure that describes the score Josh received most often. So make sure you answer the questions carefully. Then which measure should Josh use to convince his parents that he's doing well in school? And make certain that you explain your answer. So work on questions number 1 and the next page. Now we're going to take a look at example 2. For example 2, we are looking at our box and whisker plots, which we know are just fabulous ways to display data. In this box and whisker plot, we have the ticket sales in millions of dollars of the top movies in 2000 and 2007. So you can see the top one here is the year 2000, and the next one is 2007. Which data set has the greater median? So I want you to recall, with the box and whisker plot, the median is the line in the middle. And the line in the middle for the year 2000 looks like it's at $125 million. The line in the middle for the year 2007 is at 150, well, maybe 175. So it's a little bit higher. And you can see that year 2007 has a higher median? Which data set has a greater interquartile range? So the interquartile range is going to be from one end of the box, so the large number in the box minus the smallest number in the box. So if we look at the year 2000, we don't even have to do the subtraction. Just take a look at the length of that box. Let's see here. Here's our length, and the other one is much longer. So which one has a greater interquartile range? That's going to be the year 2007 has a longer box and greater interquartile range. The question asks about how much more were the ticket sales for the top movie in 2007 than for the top movie in 2000. So we want to look at the whiskers if we're thinking about the top movie. So the first whisker that we're going to look at is for 2000, and we take a look at our chart. So we have 2075, so it looks like $260 million in the year 2000. So the year 2000 was $260 million. So we're next going to look at the second whisker for the year 2007. So year 2007, here's the whisker I'm pointing at. Ooh, that looks like it's at 335,000 perhaps, or 35 million, so 335 million. Now remember to answer the question, how much more were the tickets? So we're going to subtract 335 minus 260, and we are going to get $75 million. So the difference is $75 million. All right, so now that we've taken a look at that, what I would like you to do is think about the next couple of problems and finish up this assignment. You have a great day.